Alright, so here we are with segment addition. Every time you get a problem like this, you draw the picture, label the picture. Luckily for you, it's already done here. Half of it at least. So, the picture is drawn, all we have to do is label it. GH is 3, HJ is 8, the distance from G to H is 3, that's what that indicates. From H to J is 8, so they want to know how far it is from G to J. Well, it's 3 there, 8 there, that totals 11. We add them together. Segment addition is what it's known as. So, next problem, GH is 7. GJ, this time they tell us the total length here is 32, and I have to figure out what this is. Well, if it's 32 from here to here and 7 from here to here, this must be the difference between them, 25. The point of these first two problems is that if you want to find out how far it is from here to here, it is the sum of the little sticks, 3 plus 8, to get that 11. If you're given the big stick and you know a little stick's length and want to know the other little stick, well, I have to take the big stick, 32, subtract the 7 off to get 25. 25 here, 11 here. The next problem has a little bit of algebra in there. There's an algebraic expression here for HJ, 3x plus 1. Label the picture. GJ is 45, so that's from here to here, 45, and GH is given to be 11. Now I could set up the big stick minus 11 equals 3x plus 1, or I could set up the big stick minus 3x plus 1 equals 11, or I could set up 11 plus 3x plus 1 equals the big stick. There's even one more way of thinking about this, and some people may say, well, if it's 45 from G to J, that's 11 from here to here, then what's left is 45 minus 11, that's 34. So this would have to be 34, and they would just set up 3x plus 1 must equal 34. So we subtract 1, that gives 33, divide by 3, x must be 11. We would get that same value if we set up algebraically 11 plus 3x plus 1 has to add up to 45, because when we brought the 11 to the other side, we'd get 3x plus 1 equals 34. X is 11. If we've done it correctly, but we have not double-checked to make sure that our answer is reasonable. And every single time you work one of these problems, you want to make sure that your answer is reasonable. So when I plug 11 back in, that gives me 3 times 11 is 33, plus 1 is 34. That does give the length that I thought, because 34 plus 11 does add up to 45. If you make a mistake, you can catch it. Next problem, number 4. GH is 2x minus 5. HJ is 5x plus 3, and the whole length is 72. So, algebraically, I have the little stick on the left plus the little stick on the right adds up to the big stick. Combine like terms, 7x minus 2 is 72. Add 2 to both sides, 7x equals 74, and x then would be 74 over 7, which is not a very nice number. 74 divided by 7, if I pull that up, 10.5, and it makes me wonder if there's a mistake. So, if I want to, I can double check this by approximating. 74 over 7 is about 10.6. And if I put 10.6 in here for a moment, then 2 times 10.6 is, and then take away 5, 16.2 for this expression. And this expression here would be 5 times 10.6 and add 3. 56, and then 56 plus the 16.2, 72.2, which is close. Remember, I rounded back here. So I don't think there's a mistake. I do believe that x is 74 over 7, but I will want to double check it and verify. GH, you'll notice that I did not write the 16.2. That's an approximate answer. And unless you are given directions of round to the nearest hundredth, round to the nearest tenth, we always want an exact answer. The only time to round is when you're given alternative directions. So that means I'll have to plug this ugly number here, 74 over 7, in. 2 times 74 over 7 minus 5. And 2 times 74, I get 148 over 7. Minus 5, that's the same as 35 over 7. So 148 minus 35 of them gives me 113 sevenths. Now 7 goes into 113, 16 times, and a little bit left over. That little bit, let's see, 7, 16 times is 112, so there's 1 left over, 1/7. Now, I can still double check this further. I'm going to plug in for this expression 5x plus 3. That gives me, I'll do it over here, 5 times 74 sevenths plus 3. And 5 74s is 370 over 7, plus 3 is 21 over 7. So that is 391 over 7. 391 divided by 7 is about 55.8. So it is exactly 55, and I'll find out what that 0.857 is. 7 times 55 is 385. I want 391 of them. The difference between that is 6, so it's 55 and 6/7. Now the reason I wanted to do that was so I could check and see if the 55 and 6/7 and the 16 and 1/7, when I add them together, gives me 72, and sure enough it does. So I'm feeling right on number 4. You always want to go back and double check it. GH in number 5 equals HJ. That means H must be the midpoint, and it sure doesn't look like it. But remember, our drawings are not to scale. I can put tick marks on here which indicate that they are equal to each other, though. GH is 4x plus 1. HJ is 8x minus 9. And the thing is, they are the same size, so they must equal each other. So 4x plus 1 equals 8x minus 9. 4x equals, bring the 9 over, 10. And again, we get a little bit of a nasty number. X equals 10 over 4, which is 5 over 2, or 2.5. Now it wants to know how far it is from G to J, and I have these expressions that I can substitute the 5 over 2 back into. 4 times 5 halves plus 1 gives me 4 divided by 2, I guess is what I'll do, is 2 times a 5 is 10, plus 1 is 11 for that expression. And when I put 5 over 2 in here, 8 times 5 halves minus 9. 8 divided by 2 is 4, times 5 is 20, minus 9 is also 11. They're equal to each other, so I'm feeling good about it. This side is 11, this side is 11, the whole length, 22, and that's segment addition.